Hello everyone. In this session we are going to solve LR circuit, series circuit problems. So, LR series circuit differential equation L into di by dt plus R into I, R is same as di by dt plus R by L into I is equal to E by L. This is the LR series circuit differential equation. Di by dt plus R by L into I is equal to E by L. Di by dt plus R by L into I is equal to E by L. This is linear differential equation of first order, referred to as LR series circuit differential equation. In this equation, I equals current in the circuit and R resistance in the circuit, L inductance in the RL circuit, E is an electromotive force in the RL circuit. Using this differential equation, we can find out the current in the RL circuit or LR circuit at any time t. Now, we are going to solve the first one problem in RL circuit. The question is, a series circuit with resistance R, inductance L and electromotive force E is governed by the differential equation L into di by dt plus R into I is equal to E, where L and R are constants and initially the current is 0. When time t is equal to 0, the current in the circuit I is equal to 0. So, using given data, find the current at any time. Just find out the expression, current expression in terms of time. So, this is the first one question in RL circuit. So, using given data and given differential equation, find out the current at any time t. In solution, first write on the given equation. The given equation L into di by dt plus R into I is equal to E. It can be written as follows. So, di by dt plus R by L into I is equal to E by L. Call it as equation 1. This is of the form, dy by dx plus p into y is equal to q, whose solution is given by y into e power integral of p into dx is equal to q into integral of e power integral of p into dx with respect to x plus c. Equation 1 is in the form dy by dx plus p into y is equal to q. This is standard form of linear equation. Linear means if the dependent variable and its derivative are of first degree. So, whose solution is given by, already we know that solution of linear differential equation. Therefore, the solution is y into integrating factor e power p into dx is equal to integral of q into e power integral of p into dx with respect to x plus c. This is the solution of, general solution of linear differential equation. And just we comparing the equation 1 with the standard form of linear equation, we get p is equal to, in place of p is equal to E R by L and q is equal to E by L. Using solution of linear equation, similarly write down the solution of equation 1. So, in the solution of equation 1, here equation 1 dependent variable I and independent variable t. Therefore, p is equal to R by L, q is equal to E by L. Therefore, solution of equation 1 I into, because here dependent variable y, therefore, here dependent variable I, therefore, I into integral of p is nothing but R by L with respect to t is equal to integral of q is nothing but E by L into e power R by L with respect to t plus c. In the next line, so I into I into integration of e power r by L. Already we know that r and L are constants. Here r, L are constants, therefore taken outside of the integral, remaining value is 1 with respect to t. Integration of 1 with respect to t is nothing but t, therefore I into e power rt by L. Integral of first one is equal to e by L into e power rt by L with respect to with respect to t plus c. C is an integral constant. R is same as I into e power rt by L is equal to e by L is constant taken outside of the integral, remaining thing is e power rt by L with respect to t plus c. Now again integration of e power rt divided by L. Generally we know that integration of e power at is equal to e power at divided by a. Similarly here integration of e power rt divided by L is equal to I into e power rt by L is equal to e by L into, so integration of e power rt by L is same as e power rt by L divided by r by L plus c. This is the integral value. E power rt by L integration e power rt by L divided by r by L, or I into e power rt by L is equal to e by L into r by L is same as L by r into e power rt by L plus c. Here all L get cancelled, remaining value is same as e power rt by L is equal to e by r into e power rt by L plus c. In the next line, whole equation multiply by, in this equation multiply by e power minus rt by L, we get I into I equals e power rt by L and e power minus rt by L is equal to e power 0 is nothing but 1. Therefore I is equal to e by r, again here also e power rt by L and e power minus rt by L value is equal to 1 plus c into e power minus rt by L. This is equation 2. The expression of I in terms of t, so e by r plus c into, this is c, e by I is equal to e by r plus c into e power minus rt by L, call it as equation 2. Now we shall apply the initial condition. The initial conditions are, initially the current is equal to 0 when t is equal to 0 in equation 2. Using these two values in equation 2, therefore 0 is equal to e by r plus c into e power minus 0. E power r into 0 divided by L, 0 by anything is 0, therefore e power 0 is nothing but 1. This value is equal to 1, therefore c is equal to minus e by r. This is integral constant value, c equals minus e by r. Therefore using c in equation 2, therefore I is equal to e by r plus c is equal to minus e by r into e power minus rt by L. R is same as I is equal to e by r equal to e by r as a common factor, remaining value 1 minus e power minus rt by L. This is the expression for current at any time t. So I is equal to e by r into 1 minus e power rt by L. This is the expression for current at any time t for the given differential equation. Okay. Now we are going to solve the second problem in RL circuit. The question is the RL circuit differential equation. RL circuit differential equation acted on by an electromotive force E into sin omega t satisfies the differential equation L into di by dt plus R into I is equal to E into sin omega t. If there is no current in the circuit initially, means when time t is equal to 0, there is no current in the circuit. So if there is no current in the circuit initially, at that using that conditions, obtain the current value of current at any time t. This is the second question in RL circuit. In this question, they are given the electromotive force E into sin omega t that satisfies the differential equation L into di by dt plus R into I is equal to E sin omega t. And initially, if there is no current in the circuit, using given data, find the current value at any time t. This is the second one question in RL circuit. Write on the given equation L into di by dt plus R into I is equal to E sin omega t. So, this is the given differential equation or is same as d by dt plus R by L into I is equal to E by L into sin omega t. Call it as equation 1. This is the linear differential equation of first order. Already we know that solution of linear differential equation, therefore I into this is P and this is Q is equal to Q. This one is P. Therefore I into integral of P with respect to T. Therefore R by L with respect to T is equal to Q. Q is nothing but E by L into sin omega t into e power integral of R by L with respect to t plus c. This equation is in the form dy by dx plus p into y is equal to q. Solution of linear differential equation, already we know that y into integrating factor equal to integral of q into integrating factor with respect to x plus c. I into e power RT by L, because R by L is constant taken outside of the integral, remaining thing is 1, integration of 1 is nothing but t is equal to E by L is constant taken outside of the integral, remaining value sin omega t into e power RT by L with respect to t plus c. This is equation 2. Now further continuation, we shall apply the following result. Now we shall apply the following result to find the integral in RHS of equation 2. So the formula is integral of e power at into sin bt is equal to e power at divided by square root of a square plus b square into sin of bt minus tan inverse of b by a. This is the result. E power at into sin bt equals e power at divided by a square plus b square into sin of bt minus tan inverse of b by a. Using the same formula for evaluation of this integral in equation 2. Here a is equal to r by L is equal to a and b is equal to omega. This is a and b is equal to omega. So now integrate the equation 2, RHS of equation 2, using the result we get I into e power RT by L is equal to e by L is constant taken outside of the integral, remaining thing is e power at, a is equal to e power r by L into t divided by square root of a square r by L whole square into b square omega square into sin of bt omega t tan inverse of b by a omega divided by r by L plus c. C is an integral constant, here also plus c. Therefore in the next line, so I into e power RT by L is equal to e by L into e power RT by L divided by square root of is same as r square plus L square omega square divided by L square. Simplification of denominator, r square r by L whole square plus omega square is nothing but r square plus L square omega square divided by L square into sin of omega t minus tan inverse of omega L by R plus C. C is an integral constant. Therefore, in the next line, denoting tan inverse of omega L by R is equal to phi, or tan phi is equal to omega L by R. After denoting tan phi value, I into e power RT by L is equal to E by L into e power RT by L into L divided by square root of R square plus L square omega square into sin of omega t minus phi plus C. In the next step, whole equation multiply by e power minus RT by L, we get I is equal to, your LL get cancel, E divided by square root of R square plus L square omega square into sin of omega t minus phi plus C into e power minus RT by L. In the next line, call it as equation 2. In this equation, put using initial conditions, I is equal to 0 when t equals 0. Therefore, I is equal to 0 into E divided by square root of R square plus L square omega square into sin of 0 minus phi plus C into e power 0 is nothing but 1. R is same as here sin of 0 minus phi, sin minus phi, but we know that sin of minus theta is equal to minus sin theta. Using this result, therefore 0 is equal to minus I into sin phi divided by square root of R square into L square omega square plus C, or C is equal to E into sin phi divided by R square plus L square omega square. Next line, using C value in equation 2. Using C value in equation 2, therefore I is equal to, current expression I is equal to E divided by square root of R square plus L square omega square into sin of omega t minus phi plus C. C is nothing but E into sin phi divided by square root of R square plus omega square L square into e power minus RT by L. R is same as the expression for current I is equal to, in this equation I is equal to E by square root of R square plus L square omega square is a common factor. We get E divided by square root of R square plus L square omega square into sin of omega t minus phi plus sin of phi into e power minus RT by L. Okay. This is the current expression for the given differential equation here, where phi is equal to tan inverse of omega L by R. Okay. This is the final expression, current expression at any time t for the given differential equation with an electromotive force E into sin omega t. Thank you.